Now, proof is part of the higher syllabus, and it's not asked that often, so I've put one of these down just to give you an idea of what they're after. So they want to write down an expression in terms of n for the nth multiple of 5. That's fairly straightforward. For the nth multiple of 5, the nth term is going to be 5n. If we want the 10th term, we do 5 times 10. If we want the 20th term, we do 5 times 20. So the expression in terms of n for the nth multiple of 5 is 5n. It then says prove that the sum of two consecutive multiples of 5 is always an odd number. Well, let's take the first multiple of 5, 5n. The consecutive means the next one on, and we're doing the sum, so it's going to be added on. So the next one will be n plus 1. So if I had the 5th term, 5 times 5, if I want the 6th term, it would have to be 5 plus 1, the 6th term. So we multiply this out and see what we get. Well, we get 5n plus 5n plus 5, which leads me to 10n plus 5, which when we factorise it, we get 5 brackets 2n plus 1. Well, this is an odd times an odd, which always gives you an odd answer. So therefore we've proved that it's going to be an odd. It doesn't matter what value of n you choose, you're always going to get an odd answer. The reason why 2n plus 1 is odd is 2n is even, it's 2 times table. When you add 1 to the even number, you always get an odd number, so hence the bracket is always odd. And an odd times an odd is always an odd. 3 7s 21, 5 3s 15, and so forth. Prove that the product of two consecutive numbers, multiples of 5, is always an even number. Alright, so the product means multiply. So we're going to end up with 5n times 5 bracket n plus 1, which gives me 5n times 5n plus 5, which leads to 25n squared plus 25n. Factorising common factors, we get 25n times n plus 1. Well, to prove whether this is always going to be an even number, we're not sure what value of n will take, so we try what happens when n is odd. Well, if n is odd, we're doing an odd number 25 times an odd number times, well, an odd plus 1 is even. So an odd times an odd, oh, we saw that before, it's an odd, times an even, well, anything times an even number is always an even answer. So using n as odd, we get an even answer. So what happens when n is even? Well, here we take the 25 again, is odd. An odd times an even times, well, the bracket gives us an even plus 1. Well, an odd times an even is an even answer, and an even plus 1 is an odd answer. So 2 times table plus 1 is always going to be an odd number, and an even times an odd always gives an even answer. Anything in the 2 times table is even. So it doesn't matter whether we choose n as odd or n as even, we always get an even answer at the end. So the proof questions literally nearly always come down to recognising the patterns of odds and evens in some way, and the nth term rule for certain multiples. That's the classic kind of higher level proof question on algebra.